All right, hello class. We're going on to section 2.2 and 2.3 notes. Thank you guys for the ones who came into the Zoom office hours yesterday as a class. They were great. Glad to work with you. If you have any questions, feel free to message on the frequently asked questions portion on Schoology. All right, let's get started with the notes. So there's no calculators for these sections. All right, you're gonna be expected to know how to do this without a calculator. All right. The essential question that we have, when positive and negative numbers, think of them of numbers as a number line, okay? And we want to know what are the rules to add and subtract positive and negative real numbers, okay? So to add a positive number, you move it to the right. To add a negative number, you move it to the left, okay? All right, so let's use a number line to find the sum, okay? We start out at -4, okay? And -4 is starting right there, and then we add 2 positive. So we end up here at -2, okay? You see that? That equals -2. So we go over 1, 2. We add 2. Got it? I'm going to zoom in a little bit closer so you can see. Next one, 3 plus a -4. So we start out at 3, and we add a -4. So we go back 4. 1, 2, 3, 4. Okay, where do we end up at? We end up at -1. All right? Makes sense? Next question says we start at 7, and we add -2. Okay? 7's located right here. All right? That's 7. And it says we add -2. To add a negative number, we move to the left. And that's 1, 2. And we end up at +5. Okay? We start at -3 here. And this is to go back 2. 1, 2. We're adding a negative, so we're going back. So that equals a total of -5. All right? Pretty good there? Okay, when adding two numbers that have the same sign. So when you add two numbers that have the same sign, okay, what you simply do is you combine them by adding and keep the same sign. Okay? Two numbers that have the same sign, okay, you add them, combine by adding, and you keep same sign. All right? Okay. I'm going to switch over to pen so you can see a little bit better. Okay, now when you are adding two numbers that have different sign, you combine by subtracting and you keep the sign of the bigger number. Okay, which one has a greater absolute value? So let me give you an example here. Let's write down the definition, or what we need to write underneath there first, and then I'll give you an example. So you combined, okay, by subtracting, and you keep the sign of the bigger number. And it's a bigger number in terms of its absolute value. That's key. The bigger number in terms of absolute value. Because obviously all negative numbers are less than all the positive numbers, okay? But if I have, let's see, like we have an example that we already did. Or actually we haven't done this one yet. But if I have a -7 plus 2, what I do is I say, you know what, we're going to take the absolute value of both of them because they're different signs. You have a negative and you have a positive. What's 7 minus 2? It's 5. But since the larger number is negative, I place a negative sign out front. All right? That makes sense? All right. Let's move on to the next page. The next page says find the sum. Okay? Think about the rules we just talked about. So if I have a negative 8.4 and I'm adding 2 positive numbers, a negative 0.07. These both have the same signs, okay? If they have both the same signs, I can add the two and keep the same sign. So 8.4 plus 0.7 is, all right, 9.1. And since they're both negative, that becomes a negative 9.1. All right? Number 2, we have a negative and a positive. We subtract, all right, 7.3 from 12.6, all right? That gives us 5.3, okay? And since the negative 12.6 is a larger absolute value, we keep the negative sign. We go to the negative sign, right? Negative 4.3 plus 10. So what you can do, you can rearrange this to be 10 minus 4.3, or we can just do our rule. Since they're opposite signs, okay, we take the larger number, subtract from the smaller one. So 10 minus 4.3, okay, that's equal to 5.7. And since the 10 is positive, it is a larger number, we're going to keep that positive, okay? D, we have negative 1/2 plus 1/4, okay? We need to convert them over to the same common denominator. So 1/2 is the same thing as negative 2/4 plus 1/4. Okay, we just add across. We keep the same denominator and add the cross. Okay, negative 2 plus 1 is simply negative 1, so it's negative 1/4. Okay. On E, okay, what we need to do is find common denominator as well. Okay, this is 2, this is 3. Okay, so what I'd like you to do is figure out what's the lowest common denominator. Okay, that's going to be 6. 2 times 3 is 6. So it's negative 2, 3/6. Okay, and it says plus a negative, okay, plus a negative, right, 2/6. Right? Then we see they're both going to be negatives, okay? Then we need to add them up and keep the negative sign. So we still have a 2 out front. 3 plus 2 is 5, so it's 5/6. Put the negative sign out front. It's negative 2 and 5/6, right? That's how I do that. This one, they're both the same sign, and they're both positive. We need to find a common denominator. Common denominator between 3 and 4 is 12. 3 times 4 equals 12, okay? And I have, in order for 3 to get to 12, I have to multiply it by 4. So it's 4/12. In order to get 4 to 12, I have to multiply it by 3. So then that means it's 3/12. Same as 1/4. Add them together, I get 1 and 7/12. Okay, that's your answer. All right, let's look at G here. Okay, G. I'd like you to try to do this on your own, pause the video, and then compare your answer with me. All right, I assume you just did it after you paused the video. Okay, we're going to combine the negatives first. Okay, so negative 10, negative 23 equals negative 33. Negative 33 plus 18. Okay, the larger number of the absolute value is 33. 33 minus 18 is 15, but the 33 has a negative, so we make it negative 15. Okay, on H, we can add like signs first, so the 2.5 and 3.5. So it's negative 2 plus, okay, halves equal a whole, so equals 6. Okay, larger number is that 6. 6 minus 1.2 is 4.8, and it stays positive because the 6 is a larger absolute value than negative 1.2. All right, the smallest common denominator between 4, 2, and 3 is 12. Okay, 12, or all these numbers are all these numbers can go into 12. All right, evenly. So this is negative 3/12 plus 6/12 plus a negative 4/12. Okay, see that? All right, when you see that, you can put it in. We just add across, okay? We know their denominators would stay 12. Negative 3 plus negative 4 is a negative 7. Negative 7 plus 12, or excuse me, negative 7 plus a 6 is negative 1. So it's going to be negative 1 over 12. Okay, so these are all different properties that we have. Properties of addition. Okay, yeah, the the commutative property. The order in which you add the two numbers does not change. So if you guys remember back to PEMDAS, please excuse my dear Aunt Sally. We have M and the A and the S can be interchanged. Remember, you go from left to right. Okay. Doesn't matter which order if those are the only two that you are switching around. Okay. Addition, subtraction can be either or. Okay. So here's an example of how to do that. Associative property says the way you group the three numbers in the sum does not change the sum. Okay. And this is when you're all adding. All right. So when you're all adding. Okay. Identity property, the sum of a number and 0 is the number, okay? So you add 0, you get the number. Inverse, the sum of a number and its opposite is 0. So 6 and negative 6, when you add them together, is 0. Okay, let's go on to the next page, okay? Concept 3, identifying the properties of addition. So we need to see which properties that we use for this, okay? A negative 11.9 plus 11.9, they both have the same absolute value. So we know, okay, the numbers are opposite, so these are inverses. These are inverses. Okay. See here, these are flipped around, but we also have, you see how this is a negative 8 plus a negative x, and this is a negative x plus 8, okay? The order's flipped, okay? Also, you have, these are not going to be equal, so this is a mistake. So we need to make, we can cancel out that negative sign so that there's a mistake in the notes. But the order's flipped is all I want you to really notice there. When the order's flipped, it's commutative. Okay, next part, when you add a 0 to any number, it equals itself. So that's identity. If you guys remember, the identity property of multiplication is whenever you multiply something by 1, it's itself. Okay. Here, we are changing what we do first, how we associate first. It doesn't matter if you add the 4 and the 5 together first or the 3 and the 4 together first. You still get the same thing. It doesn't matter how you associate them. It will be the same. So it's associative property. Okay. E, okay, we are flipping the order again. All right. And we're also, not only are we flipping the order again, we're also changing the grouping. So you have both of them on here. You have the commutative and associative. All right.